Hi guys, I'm Paweł from Web Mentor. In 2019, 2,841 people died because they were distracted while driving. It is estimated that about 400,000 people were injured in accidents involving distracted drivers. Researchers are trying to understand how human multitasking works for years now. So far, the conclusion is that people can't really multitask. Our brains can handle, for example, singing and playing the guitar at the same time, but try to do this when you see the notes for the first time. Musicians train and train to be able to do these things at the same time. We are not really made to multitask. But what about JavaScript multitasking? JavaScript is a single-threaded environment. This means that most of the application logic is executed in a queue in a single thread. We can get some form of apparent parallelism by scheduling portion of the application logic to be delayed by using functions like setTimeout or requestAnimationFrame. But this is not really a parallelism. The task is just executed later, but still in the same thread. For just a simple website, it's not really a problem, but today a web application can do so much, and often it has to process a lot of data. If not handled properly, an application can choke the main thread with a single task for so long that the browser window shows the application not responding dialog with an option to kill the tab. This is happening when the function that is being executed is not returning to the browser's main loop, and the browser cannot process user input. So what can we do when we have a task that takes seconds to finish? One of the options is to split the data that is being processed into chunks. Then the function processes each chunk separately and schedules another task to process the next chunk of data. This way, the function returns to the main loop, and the browser can process user input and other tasks. This solution can be complex for less experienced developers, as it requires to create a mechanism to call a function and execute the callback when the data is processed. You could create a new class that processes data and holds a reference to the resolve function of a promise, for example, returned by the function call. I've created a class called deferred read, which is actually what we were discussing just before. This class reads all entities from a data store, the IndexedDB data store. And I've created a class that just puts some data into the data store and reads data from the store. The created data is some kind of contacts. It has some ID, it has start property, it has name, email, and phone. But it doesn't really matter, it's just the data. So the implementation of the store is very simple. It only has the open property that just returns the reference to the data store in an async operation. It has some close function. It has populate data that just creates a random data using Faker library. It has a function to clear the data, count the data, and read all data in one call. We're gonna get to this in a second. So our deferred read class sets a chunk size to 200, and that's gonna be 200 items per one transaction to the data store. And this is our chunk, this is our deferred task chunk. So for each 200 records, the function gonna stop and queue a new macro task in the event loop that just reads another chunk of 200 data. The main run function that actually executes the entire logic just returns the promise, which sets the private resolve and reject functions, which is just a callback function from the promise, and runs the private run function. The private function just opens the store, creates a new transaction, gets the reference to the store, to the contacts data store, opens a cursor, and sets the I property, which is the index, to 0. So we're gonna use the index just to make sure that we exceeding the exact number of records in one transaction. So when the cursor is open, this is on success function. Just for convenience for TypeScript, I just do some casting to request and then to the cursor. And the logic is as follows. If there is no cursor, that means that we have no more results, so we can resolve, we call the private resolve function, with the current data. I'm gonna get there in a second. I'm gonna skip this for a moment as well. So when there is a value of the cursor, which is our contact record, I just add it to the data array. I increment the index value, and now I can compare whether index is the value of the chunk. And if it is, then I set the private advanced property, which is equal to the size of the data. So I'm doing this, so with the next call, the advanced property is set, and I'm telling the cursor to advance for so many records exactly. And the cursor will just skips as many records as there's been read already. Then I set the advance to 0, so it won't be called with the next call. So when the chunk size is reached, I set this advance property, and I schedule a macro task to execute the private run function again. If it doesn't, I just call cursor continue function, and the whole operation repeats until one of the conditions are met. So pretty much that's it. So let's see how this works in action. This is the application I've created. It's nothing fancy, just a very simple web application. These are the buttons, which is populate, clear, count, and run. And the deferred task just connects buttons with the action. So the populate just runs the populate data function on the store, and the run button executes the deferred read task. So let's see how this works. So I already pre-populated the data, and right now there is 40,960 items in the data, so we can actually create a few more. Let's try. Okay, so right now we are having 61,440 items. So let's call get data. It's gonna take a while. I'm gonna explain that in a second. So let's just skip to the end. All right, 29 seconds to execute these functions to read 61,000 records. Okay, that might seem a lot, but we read a lot of records, and we didn't create an opportunity to hang the main process. The side note here, the IndexedDB is asynchronous by nature, so you never actually can hang a main process with it. It's not really possible by just reading or setting the data, unless you do some kind of transformation of the data for each record. That actually takes a lot of time. That would actually cause the main thread to hang. But with this example, I just want to show the principle of how deferred task can work. So I just read all this data, and it takes so long because after each call, after each 200 batch read, the whole operation repeats. It opens the data store. Yes, it's already open, but it creates new transaction. Then it gets the data store. Then it opens cursor. Then it advances for so many records, and then it just goes over the loop again and again and again. And this happens hundreds of times in this loop. It just takes some time to execute it, but it's safe to do this in the main thread because this batch is just too fast to create any opportunity for the main process to hang. If your application is a Node application, then you have a whole arsenal of functions to execute code in another thread, and either stream the results back to the main thread when they become available, or return the results of the entire operation. Because it's all happening in other process, you don't really have to worry about the user's main thread. A browser doesn't have that many options for spinning off new processes like Node, but there is an option to create a background task that is a web worker. You create a web worker by passing the location to the worker's file as the first argument, and voila, the worker is ready. I mean, you have created a separated process with a new context. The process loads the file pointed by the constructor's first argument. Nothing really happens now. We need a communication channel with our worker so we can send the data in and wait for the response. For this, we use the postMessage function that is available on the worker's instance. The postMessage function accepts any kind of data that can be serialized. You can think of it the same way as serializing a JavaScript object to a JSON. There's only a few exceptions that can't be properly serialized, like functions or a reference to any DOM object. Anyway, we can send some data with the postMessage function and listen to the message event on the worker instance for the data returned by the worker. It's that simple. What is happening inside the worker is more interesting. First of all, web worker context is not the same as the browser window context. You don't have the window object and you don't have the DOM. All APIs that need access to the DOM are either non-existing or return the null value. Otherwise, everything works the same. Well, instead of the window object, you have the self-global object. You use it like the window object, but it has a different set of APIs available. But let's not worry about it right now. Usually the Mozilla Developer Network documentation pages have information about whether a function you want to use is available in a worker or not. In most cases, the answer is yes. Inside the web worker, you can access I/O operations like making HTTP requests to other services. This is subject to the same coarse restrictions as your main context. You can also load more scripts with the import scripts function. This way, you can share your application logic with the background processes. And yes, I said processes because you can create more than one background process. There is a new API for loading scripts in a worker, but more on this in a minute. So to receive a comment or a message from the main process, the worker has to listen to the message event, just like we did in the main process. This is the same message event with the data object on it. This way, you can create complex logic for your worker that includes several different procedure calls in the same worker. After the worker finishes, it calls the postMessage function on the self object with the result of computations. In short, this is how you use web workers. You create a process, you pass input data, and you wait for the computation result. Workers should be used when expensive work is expected to be performed by the application. This way, you can unload this work to another process and keep the main thread to perform other regular tasks. Let me quickly show you the principle how the web workers work. So I've created a very simple web worker just to visualize the principle. I just have one button, which is send message, some output, and the simple worker logic is just to create a web worker. And like I mentioned before, the worker just accepts the path to the actual worker, to the class, to the JavaScript file that is executed in the background worker. So I attached event listener to the message event to the worker, and the message event has the data property on it. So I just gonna print the data as it comes to our output element. And when I click the button, I just send Pavel to the worker through postMessage function. The simple web worker, which is the implementation of the worker, this is what is happening in this process. has it's listening to the message event, which is the same message event, the interface message event, and reads for the data. And in this case, it's just immediately returning the same data with I read you. So let's see how this works in a web application. So yeah, ready for demo, send message, I read you, Pavel. This is basically how web workers work. You send some data through the post message function. It can be any serializable data, and you just wait until you read the response. So let's change my previous example of the database task. So it's pretty much the same data store. I haven't changed anything in here, and the web worker is pretty much the same. It still has the same function calls, but I've created something I called a store proxy. So for this to work, and I think it's a right architecture, I created a proxy that has the similar to the actual store, that the one that works in the main thread API has the same function calls, but underneath, inside the proxy, it actually, instead of calling the database, it sends the data to the background process, to the worker. It's kind of RPC call with an API. So let's see how the store proxy and store worker actually looks like. So our store proxy has an ID field that holds just an identifier. We're gonna use it to identify the function call in the worker. So because workers are asynchronous, they don't really support promises, and it doesn't really make sense to support for them to support promises. You send a message and you just await for a response, and you need a way to identify this response. And I'm using this ID to identify the particular response to a function that is in the queue map. So the queue map holds the ID in its key argument, and the resolve and the reject function from the promise, and of course the worker. Because originally I defined the worker, this data store, as a ECMAScript class, I'm gonna use the type equals module value here. I can do this because I'm running this example in Chrome, but this type module is not really widely supported just yet. It's as new as ECMAScript modules. So I have the same functions, populate data, clear data, count data, and read all data as in the data store. These are the same operations, populate data, clear data, and so on and so on. But instead calling the data store directly, the IndexedDB, it actually sends a message with the populate data with the function name to the worker. And the send message function takes a topic, which is just the name of the function to call, and optional arguments that you can call. We don't really use arguments in here, but you can just pass any argument, for example, if you're adding a new record or whatever. So what I'm doing is I'm generating new request ID, which just increments the ID and returns the previous ID. We just creates a promise and adds this promise, resolve, and reject functions to the queue, which will be returned by the send message and eventually by the function that was originally called, and sends a message to the worker through the post message. And the message is as follows: as ID, which we just generated, is the topic, which is the function name, and optional arguments. And in the worker store, however, now I use the reference to the store. I initialize the store, and in on message event listener, I just read the data. I execute the function, which is the topic, and because these are the same names, I can just use this notation and optional arguments if any. And immediately I am creating the response object with the ID, with the received ID and I am awaiting for the promise that was returned by the store function call. If there is an error, I create an error object, which is just an error equals true and the reason of the error. And if not, the result is set with the result of the promise. And I send this message back to the proxy. In the response function, I just read the data and destruct it to its properties. If there is an item, if there is no item in the queue, I just cancel the entire operation. So I read the data, the promise from the queue, and delete the item. So I don't really need it anymore. If there is an error, I just return this error through the promise reject function, and if it's working, then I just call the resolve function. So that's pretty much it, and this is very simple architecture. And when the populate data, so no, not populate, read all data is called, what is happening is that the read all function in the proxy, read all sends the message to the worker. Worker is executing this function in the data store, returns this promise to the proxy, and proxy returns it to the worker. Pretty much that's it. So let's see how this work. So let's run this task in the background worker. It's the same data, the same number of items. I haven't changed anything, and because the worker works in the same domain, it has access to the same data as this website. If I would be running the worker from other contexts, I wouldn't get the same data. So let's call getData, and voila, 1.3 seconds and the same number of results. There is a huge difference between calling a deferred task and the worker. It's huge difference. I'm conducting the entire operation in one transaction, which is ultra fast. It's actually the fastest as it can be. And I read the same number of results. Great. These were the basics of running web workers. There is a new way how the web workers work, and this involves ECMAScript modules. However, at the time of recording this video, not all browser vendors implemented it. According to the new web worker specifications, the web worker constructor takes a second argument, which is an object. It can have the type property with classic or module values. Classic is assumed by default, but when you set this value to module, then the import scripts function disappears from the web worker, and you can use the all-new import statement. It is so much more convenient to use, and I can't wait until the default option will be module, but I think we have at least a decade before that. That's it for today, subscribe to the channel, and thanks for watching!